After you learn the basics of SQL, you'll probably come across some complex SQL queries. In this video, you'll see an example of a complex SQL query and watch the steps I take to understand it. You can use this to understand the kind of steps you might take to understand your own complex queries. This is an example of the step-by-step process I cover in my Understanding Complex Queries course, which is the complete process I follow for understanding complex SQL queries. You can take this course as part of the Database Star Academy, the online training platform for database design and SQL. Check out the link in the description for more information. Here is the query we're going to use in this video. Our goal is to understand what this query does. It was sourced from an SQL practice question on the Coding Ninjas website. We'll be using MySQL Workbench running on a MySQL database for this, but the query and the concepts can apply to other SQL databases and tools. I've also prepared some sample data to use for this video. You can find the links to the SQL scripts for these in the description below if you want to follow along. Let's look at this query. At first glance, we can see there is a lot going on. There is a with clause at the top, which means it uses a feature called a CTE or common table expression. We can see some select statements within select statements, otherwise known as subqueries. We can see a union all statement, some grouping, joining between tables, and some aggregate functions. This looks like a pretty complex query. Where do we start? The first thing I like to do when trying to understand a query is to format it so it's easier to read. This doesn't change what the query does, but it's a good first step to take. You may not be able to save the new format of the query if this is within some source code you don't have permission on, or within another tool, but that's okay. With many SQL editors, there is an automatic formatting feature. This would be called Beautify or Format SQL or something like that. We'll try using the auto formatter first. In MySQL Workbench, this is called Beautify, and it's this little paintbrush icon here on the toolbar. Click that and the query will be formatted. Now, sometimes the formatter doesn't work that well. We can see here that the query looks similar to before we click the button. That's okay, we can manually format the query. You can manually format the query by adding in new lines, indenting, and spacing throughout the query. A lot of this comes down to personal preference, but there are a couple of things I'm doing here. I'm starting each select query on a new line and indenting it. This will make it easier to see where the subqueries are. I'm also separating the case statements onto multiple lines, as I find that easier to read. I haven't changed any column aliases as I don't want to change what the code does. I also haven't capitalized any of the SQL keywords. I usually prefer to write SQL keywords like select and from in uppercase, but for the moment I just want to make better use of spacing, so I'll leave them as they are. Here is what the query looks like with this formatting done manually. I think it's a little easier to read. Now let's work out what it's doing. Let's start by looking at the first common table expression, or the first item in the with clause at the top of the query. If you haven't seen one of these with keywords before, it's a feature that lets you define a select query, give that query a name, and then refer to that named query later in your script. It's great for simplifying your query and making it easier to understand. After the with keyword is the word CTE. This is the name given to the subquery. It's normally a good idea to give your queries an informative name, so a name of CTE doesn't tell me anything about what it is. Inside this query, we are selecting two columns, the IDs and the team name. We select this from the teams table and then join to some more code inside the open brackets. The code inside the brackets here is a subquery, and in SQL you can join to a subquery like this. The database will run the subquery, return the results, and treat those results like a table which you can then join to. So we're selecting some data from the teams table and joining to a subquery that gets some data from the matches table. There's also a union all in there. Let's start by looking at what's inside these two tables. I'll run a simple select query just on the teams table to see the data. This will help me visualize what the query is doing when it refers to the different fields. We'll run select star from teams. We can see the results here. There are two columns. There is a team ID which looks like a number and a team name which is a text value. This is actually a list of English football clubs. This is good to know. Whenever we see the team ID in our query, we know it's a number, and we know what the team name looks like. Let's look at the other table called matches. We'll write a select star from matches query and run it. In the results, we can see a few columns. There's a home team ID, which is a number. Next is away team ID, which is also a number. We have home team goals and away team goals. Both are numbers. So I'm not quite sure what these columns mean at the moment, but we can see there is a concept of a home team and an away team. There are some ID fields and some columns for goals. We'll learn more about these fields as we look at our main query to see how they are used. Let's go back to our main query. Back at the start of the main query, we had our subquery. We have this query that selects some data from matches, then has a union all, then selects more data from matches. The union all keyword is used to combine the results of two queries into one result set. To understand everything here that's inside this query called CTE, we need to know what this subquery here does. So let's copy this select query, both of them including the union all, and paste into a new area of our query editor. Let's look at this query. We are selecting the home team ID column from the matches table, and we've used the as keyword, which gives this a column alias called IDS. This means the results will show a column header of IDS. We then have union all, and we select the away team ID from the matches column and call it IDS as well. We don't actually need to use the as keyword here again, because the first query before the union all will name the column, but that's okay. I won't change the query here for now. Let's run this query. We can see the results here. It shows a single column called IDS and many rows with numbers in them. We can see there are numbers that are repeating. If we look at the query, we can see what it's trying to do. It's selecting the home team IDs and the away team IDs and combining them into a single list. The data is from the matches table, so we can say this query gets all of the home and away team IDs that have played a match. Let's go back to our main query. We can see this subquery here, the one we just ran, is being used in a join. Before we look at the next part of the query, let's do something to help our understanding. We'll add a comment to our query to explain what this subquery does. This comment is not executed in the query, as it is ignored by the database, but it's something we can add to help our understanding. In all versions of SQL, you can add a comment by using the / and a star character. This is called a multi-line comment. You can add a single line comment as well, and the method is different in each database, so we'll stick with the multi-line for now. I'll start the comment like this, then end it with a star and a slash. Within these characters, I'll describe what this part of the query is doing. This can make it easier for us as we work out what the query does. Let's keep going with looking at the SQL. Above that subquery, we have another piece of SQL. We are selecting the IDs column and the team name column from the teams table and joining to our subquery. The IDs column comes from our subquery, which is the list of IDs. We also get the team name from the team table. We are joining on the team ID and the IDs field from the subquery. Let's copy this query and run it by itself. We can see the results here. We can see the ID field and the team name. Now we can see the data is repeating again, just like when we ran the query to get the IDs. I'm pretty sure that this is happening because we are using the union all keyword, which combines the results but does not eliminate duplicates. Union all is great in many situations, but it may be better to use a union instead to remove duplicates. But I won't make the change because this video and process is all about understanding the query, not improving it. Alright, so what's next? Let's go back to our main query and add a comment to this part of the query now that we know what it does. We'll add a comment here to mention that it is getting the team IDs and team names. So that's what the first CTE does. We're making progress. One thing I could do is rename the word CTE here to something more descriptive, such as team names and IDs. But we won't make the change yet. Let's move on to the second CTE, which is called CTE2. This is quite a bit longer than the first one. It's selecting a team name, then there are a couple of case statements, and then a from keyword. This subquery selects from another subquery, which gets data from the CTE here and the matches table. After that, we have a group by statement and then the end of the second CTE. Let's start to understand what this is doing. Like the first CTE, I find it best to start at the innermost query. So we'll look at this subquery here and work out what it's doing. This subquery here says select star from CTE. The name CTE here refers to the CTE at the top of our query. This is the one that we looked at earlier in the video, which found the team IDs and team names that had played a match. It then has to join onto the matches table. This join condition is interesting. It joins on the IDs field being equal to the home team ID or the IDs field being equal to the away team ID. This is not something I see very often, but I suspect it will join the two records if either of those two conditions are met. This is helpful in situations like this where there are two foreign keys or IDs such as the home team ID and away team ID. Let's copy this query and paste it into a separate query and run it. We can run the query, but we get an error message. In MySQL, it says the table CTE does not exist. This is because the query is selecting from something called CTE, but in this query there is no mention of that CTE being defined and there is no table called CTE. There is a solution to this. We can copy the with clause from the main query, the one that defines the term CTE, and paste it here. Once we have pasted it, we can run the query again. Here are the results. We can see more data than before. We see the team ID and the team name. We also see the home team ID, the away team ID, home team goals and away team goals. It looks like it's showing the team information and the match information for that team. The first two columns, the IDs and team name, are from the CTE. The rest of the columns are from the matches table. Ideally, in the query, we would not use select star as it's not clear which columns are being used. A better way to do this would be to specify each column, along with the table name or table alias. So there's a possible improvement for the future. Also, we can see that the rows are still duplicated. We'll see if this is addressed later in the query. Let's add a comment to our main query to describe what this is, which finds teams and their match information. Let's look at the next query above it. We can see this selects a few columns and then a from keyword, then the subquery we just saw. After the subquery, we have a group by clause. It says group by 1, 2, 3, 4, 5, and 6. I have a suspicion about what this is used for, so we'll see if that's right in a moment. Let's copy this query into its own query to run it by itself. We'll also need to copy the with CTE like we did in the earlier query. Let's run the query. We can see the results here. We can see the team ID and team name, then the home team ID, away team ID, home team goals and away team goals. It looks very similar to the previous query. It shows the same columns. However, you may have noticed one big difference. The order of the data is different. It may seem like the duplicates have been removed. However, we can see that there are some records that are repeated. We have several rows here for Arsenal, for example, but the other numbers are different. It looks like the order of the data has changed. This happens occasionally. Some keywords in SQL, such as union or group by, could cause the order of the results to change. If we want to have the data in a specific order, we use the order by clause. We may see that later in the query. Now, what's this group by clause doing? If we look at it, it says group by columns 1 to 6. First of all, I'm not a fan of specifying the number of the column because it's volatile, and if we change the columns or the order of the columns, it can break the query. Also, there are no aggregate functions like sum or average being used, so there isn't any need for the group by. I suspect it's being used to try to eliminate duplicate rows, because grouping by each of these columns will mean only one row is shown for each combination. But the group by here doesn't do anything to the results. There is still one row shown for each match played for each team. We'll see later in the query if this is an issue. Let's add a comment to the main query and move on to the next part of the query. We've added a comment here to say what this inner query does. Now let's look at the outer query in the CTE. It first selects the team name and then we have a case statement. The case statement is used to perform conditional logic on a column. It's kind of like an if statement in SQL. This case statement here says when the IDs column equals the home team ID, then return the home team goals column. The else statement says to return the away team goals column. Finally, it says end as goals for. This end keyword ends the case statement logic. The as keyword defines the name of the column, which is called goals for. So this case statement is saying if the ID matches the home team, show the home team goals, otherwise show the away team goals. This logic seems to calculate the goals that this team has scored. The next case statement is similar. It says if the IDs does not equal the home team ID, show the home team goals, otherwise show the away team goals. The statement ends with the name of goal against. So this seems to calculate the number of goals scored against a team, depending on if they are the home team or the away team. We then have a from keyword, which selects from our subquery. We scroll to the bottom of this subquery and there is no additional logic. Let's try to run this query by itself. We can copy it to a blank section in the script. We'll also need to copy the with CTE part. We run the query and see the results here. We have the name of the team here. We then have a goal for column with a number, then a goal against column with a number. If we look at the number of rows, we can see there are still 760. This is the same as our other queries, which means it's showing 2 rows for every match, one for the home team and one for the away team. We've essentially shown the team name, the goals for and goals against for each team in every match. This is what the second CTE is doing. Let's add this as a comment to our main query. If we wanted to improve the query, one thing we could do is rename CTE2 to something better, but we won't do that now. So we know what both of our CTEs are doing. What's next? Let's look at the final select query at the bottom. It selects the team name, then a count function, then a few sum functions, then from and then a subquery. Inside the subquery, there's a select keyword and a case statement. After the subquery, we group by a column and then order our results. Let's start to understand this part by starting with the inner query. We'll copy the query so we can run just this part. However, this time I've copied the entire query and will remove some parts of it because we need both CTE and CTE2 in the query. I'll remove the outer query here, the group by and the order by. This is what we're left with. Let's run the query. We can see the team name, the goals for and goals against, just like we saw in the earlier query. We've got a new column here called points. Where did this come from? We can see in our query we are selecting all of the data from the CTE2 and adding on a case statement. This case statement has a few things in it. It checks if the goals for is less than the goals against, and if so, it returns 0. If the goals for is greater than the goals against, it returns 3. If neither of those conditions are true, for example if the values are equal, then it returns 1. So for each row, if the team has a higher goals for than against, it gets 3 points. If it's equal, they get 1, and if they have less goals for than goals against, they get 0 points. So to simplify that, we could say teams get 3 points for a win, 1 point for a draw, and 0 points for a loss. We can look at the results again and see that rows match this logic. We see some 3 values, some 0 values, and some 1 values. Let's return to our main query and add a comment. We've added a comment. Let's return to the main select query here. We can see that we are selecting the team name column. Next, we have a count function. This is counting the team name column and has an alias of matches played. So this should show a number that represents how many matches have been played by that team. The next column is the sum of the points column, which is then called points. Next, we sum the goals for column and call it goal for. The reason we give an alias to these columns is that if we don't, the column name will actually be called sum bracket goal for bracket. We want to give it a more friendly name, which in this example is goal for. The next column sums the goals against. The last column here sums the goals for and goals against values and calls it goal diff. This means we are calculating the difference in goals for each row and summing them together. This should show the difference in goals for the team. After our subquery, we have a group by statement that says group by 1. This means we are grouping by the first column, which is team name. I think it's better to specify the column name here, which would be team name, but I won't change it. This group by means we will have one row for each team name, and the count and sum values will be calculated for each team name. Finally, we have an order by clause. We order by the points value in descending order, then by the goal diff in descending order. Let's run the query. We can see the results here of the entire query. We can see the team name, the matches played, their points, goals for and against, and the goal difference. The data is ordered by the points in descending order. We can see there are only 20 rows, one for each team. We have aggregated all of the match data into one row for each team. So what is this query doing? It's calculating the league table for the Football League. It calculates the goals for and against for each match, calculates the points and the difference in goals and ranks them by points. We can add a comment to the top of the query to describe that. We saw there are a bunch of changes we could make to the query just to make it more readable. There may also be some performance improvements we could make. I'll cover these changes in another video, as there's another process I follow to make changes without breaking the query. So that's the process I would take to understand a complex query like this. We broke it down by looking at small parts of the query first, which were the individual tables, then expanded to look at the subqueries. We added comments to parts of the query as we went along to help our understanding. If you like this video, leave a comment below and subscribe to my channel. If you want to learn more about database design and SQL, visit my website at databasestar.com. Thanks for watching.